Hey guys, hope you are enjoying these videos. In this video, we'll talk about a very important reaction. Normally, it is under heterocyclic chemistry, and this will be very useful for students in masters or MTechs or other MSc chemistry and other places. So we'll see. This video is basically it's a synthesis of a compound known quinoline. No doubt, it's a synthesis of compound known quinoline. And what is quinoline basically? You can draw a ring like this. And next to that you can draw one more ring keeping nitrogen here and do the proper aromatization of this. This is called quinoline. So how we form this quinoline? What is the method of formation of this quinoline? Quinoline is basically formed when a primary aromatic amine, okay, let's say you can take aniline for that matter, primary aromatic amine like aniline reacts on so we have compounds like what do you call acryldehyde. Okay, so glycerol, if you heat with dehydrating agent, you get acryldehyde. So this is heated with nitrobenzene, glycerol, concentrated H2SO4, all right, and FeSO4. So these are the things which are used. Quinoline is formed, and this synthesis is known as Skraup synthesis. So now nitrobenzene, what is the role of nitrobenzene in this reaction? It is acting as an oxidizing agent. That's the main role of it. So we'll see where will it be used and what it will do. And what is the role of FeSO4? FeSO4 role is to make reaction less violent. These are the roles of these two agents. So we should start with this reaction now. So what is the mechanism of this reaction? In this reaction, it is generally believed, because there is no certain reaction mechanism for this, so generally believed that the first step of the reaction is conversion of glycerol into acryldehyde. And we know if you draw glycerol, which is CH2OH, CHOH, CH2OH, with the presence of KHSO4 heating, it becomes CH2 double bond CH, CHO, which is called acryldehyde or acrolein. This is also called acrolein, right? So this acrolein is coming up and reacting on aniline in this particular reaction. So let's see this thing. I'm keeping N in such a way that I get N somewhere here. So I'm just drawing it in same way, and you can also do the same. So CH2 double bond CH, and after that we can say C double bond OH. This kind of group it is drawn. So what are the steps for it? We can say the reaction proceeds like this. In step 1 we can say this will attack here, this will move, and this can become O minus. So let's do that. Let's try to write it. We can say the ring is given like this. We have NHH plus, we are joining this thing here. And then next step, this is a double bond. This is O minus and this is hydrogen. So when you draw this O minus and hydrogen, you do one thing, that while drawing this thing CH, now count how many carbons, 1 carbon, 2 carbon, 3 carbon, and here there's a loss of 1 carbon. Let's draw it properly. So when you just connect it, after connection this is a single bond, then next a double bond, and then after this double bond we have O minus and H connection here. So now if you count, it is correct, 1 2 3, 1 2 3. All right, so this is fine. Now O minus is there and we have NHH plus. So the next step, what could happen, this O minus can go and grab hydrogen from NH plus. Result would be a ring we can draw like this. NH is here. In the next step, you have the single bond, then a double bond. On this double bond, one OH has come up. H is definitely here. We can draw this structure. Can we tautomerize this? So after tautomerization or tautomerization, both are correct. Z or S, both are correct. So what we use here is, after that the structure could be modifying to NH, single bond, double bond. This can become double bond OH. So we can get this kind of structure. Again, we have to ensure the number of carbons are same, 1 2 3. Here also 1 2 3, right? So that's correct. So once you get this, what is the next step? In the next step, with H plus water presence, what can happen? This C double bond OH which is drawn can be given H plus, and the ring can attack under SEAR route to this place. So what will it be giving you once it attacks? So we can say once it will attack, it will form this kind of structure where the ring is there, like this we have drawn. We are connecting this with this. OH is there, H is drawn, and then we have NH here at this place. So this kind of structure we have reached. So we are very close to the answer. Now you can, I think, visualizing why answer will come up like this. Removal of water. So we can say OHH are available here. So removal of water can be done, which will give us with heat or something. Even the medium, if we can take help of base or take help of some NH2s, we can do that. So it will become double bond at this place, and at this place it is N lone pair hydrogen. And finally, we are talking about an agent which we have used for this part, which is nitrobenzene, okay, which we have safeguarded for this last step. So what is the role of nitrobenzene? It is being used in this reaction as an oxidizing agent. So nitrobenzene can be brought in, it can oxidize the whole thing, and the structure could be 6-membered ring, next to that a 6-membered ring with nitrogen, and being oxidized, this H is gone, and this is now quinoline. Now, few important things here that we should keep in mind, that this synthesis may be carried out with any 1-degree aromatic compound in which at least one ortho position to amino group is vacant. So at least one place should be vacant, okay. So one ortho position should be vacant, it should not be occupied. If a strong OP directing group is present in meta position, for example OMe or something, then it can be again forming some different kind of compounds, and this reaction is largely used for synthesis of member of different type of quinolines. So I hope you understood the whole reaction and you understood what is the process of formation of quinoline with this particular video. Thank you very much. Keep liking, subscribing, sharing, and you can demand more videos if you have already subscribed. Thank you very much.